Okay, so what we're going to do is we're going to work on number 34 on page 123. Oh, 123. And what we have here is we have a problem where we have a crate. And this crate has a mass of 35 kilograms. And on this crate is a guy. And the guy has a mass of 65 kilograms. And the crate is standing on a floor right here. And for the first part of A, what they want us to do is find the force, call it the normal force, that the ground is exerting on the crate. Well, the mass of the guy and the crate are both figured out in the force of gravity, and their combined force of gravity is pointing down. Now the force of gravity is equal to the mass of the two objects. So we have the 35 kilograms from the box plus the 65 kilograms from the guy times 9.81 will give us our mass times gravity. That'll give us our weight, which would be 981 newtons. Pretty much because this is going to add up to 100. And 100 times 9.81 is 981 newtons. So we have, and it's going to be negative because it's pointing down, so we have our arrow. So we have negative 981 newtons pointing down. So since our normal force here is 0 because the box and the guy are not moving up or down, we know that our normal force is going to have to equal 0 equals our normal force minus our force of gravity. Since they have to equal 0, that means our normal force has to equal 981, and that's it. That's done for part A. For part B, we're looking at the force that the box is exerting on the guy. So if we look at a drawing here, we have the guy. As always, we draw our forces. The force is acting on the guy. We have force of gravity pushing down. And the thing that's pushing the guy up is the force of the crate. So we'll do that really good. And then we have the force of the crate pushing up. These are the only forces. Now again, this guy is not falling down or he's not moving up. So we know that our net force in the y direction is pretty much going to equal 0. And since our only forces are our force of the crate minus the force of gravity, then the force of the crate has to equal the force of gravity. So the force of gravity in this case, we'll do it up here, force of gravity is equal to mass times gravity. The mass of the guy is still 65 kilograms times 9.81 meters per second squared gives us 637.65 newtons is the force of gravity. So we plug this into our equation, we get 0 is equal to the force of the crate minus 637.65 newtons, which means the force of the crate has to equal 637. Accidentally deleted that. So basically, we found the force of gravity. So then we found out that the net force has to equal 0 because the guy's not moving up or down, which means that the force that the crate is exerting up has to equal the force of gravity pushing down because they have to cancel each other out. So that means the force of the crate is 637.65 newtons.